Hello, welcome to AT&T ThreatTraq for April 8th, 2014. This program provides network security highlights, discussion and countermeasures for cyber threats. Today we have a few stories we're going to cover. The first one is about the Heartbleed bug and how that's leaking memory contents of OpenSSL activity. To let you know who we have here on the couch today, we have Matt Keyser, security analyst extraordinaire, as well as Stan Nurilov, also extraordinary security analyst as well. And the best security analyst of all, Brian Rexroad, is on the phone via remote. Thanks, guys, for joining me. So let's jump into the first story here and the Heartbleed bug. What can you tell us about that one, Matt?
So this one is probably the biggest news of the week, if not the month, and it's going to be a contender for news of the year, I think. The Heartbleed bug is a bug in the OpenSSL package, which is a very popular SSL implementation used by Linux. In particular, it's known to be used by Apache and Nginx, which are two of the top web servers that are out there. Now, the bug is in the code for the Heartbeat extension for OpenSSL. And what the Heartbeat extension is sort of a keep alive. It keeps the connection alive when traffic isn't being sent. The bug is that Heartbeat requests, when they're made, they are sent with a small amount of data and a field that tells you how long that data is supposed to be. Now, the sender will send it, the receiver will receive it, look at it, and send back, in theory, that same amount of data, the exact same data, because it's sort of a back and forth, like a ping pong sort of thing. But if the sender specifies the length of that data as longer than the actual data is, some extra data will be taken out of the memory of that server beyond where it's supposed to be. Now, because of the size of the field that can be specified, in theory, this goes all the way up to 64 kilobytes of memory. I know Stan has something to say about that. But that means that you can grab entire sections of memory, whatever happens to be in memory on the server, and that'll be sent back to the sender. So what's been found is that sometimes this will contain, SSL keys. Sometimes this will contain usernames and passwords, URLs, session cookies. So pretty much anything.
So basically what's happening here is there's a tool, and it's an exploit that's been used in the wild. We know that there are tools out there to do this that can basically bounce up against an HTTPS server and exploit that tool such that what comes back is whatever happens to be in memory of that web server at that time. So you might see some arbitrary content from someone else's session that just happened, a few seconds ago or maybe a few minutes ago. And in that, there might be some useful content like cookies. So you could, use someone's cookie to log into that same website as them, or login credentials, things like that. And it comes back in clear text, I guess, right? Even though it was really part of an HTTPS session at some point. So you're getting back data that's not yours, it's from someone else's session probably earlier on, right?
Correct.
Yeah. It's interesting how the proof of concept code, the original proof of concept code that was released, has already been modified many times by people to create a scanner and to create a memory scraping tool as well to help find cookies and passwords as well. So we expect a lot of copycat behavior out there.
Yep. One of the things. Oh, I'm sorry.
Well, to bring up the point about the 64 kilobits, this is just a technical note. When studying the proof of concept code, we noticed that even though the theoretical limit for that field was 64 kilobytes, actually in practice, the code is using 16 kilobytes maximum to be returned.
That's in the RFC, isn't it?
And actually it is in the RFC. So it's interesting how even when you modify the proof of concept code, the exploited server will only still send back 16 kilobytes of information. So I thought that was interesting that there is a limit to the arbitrary access to memory.
Well, in any one request.
In any one request. That's actually an important point, Matt.
That you can keep making requests to the server over and over.
Reiteratively getting more and more whatever arbitrary data. You can't specify what you want, but you just keep getting other people's stuff from their sessions, right?
I think one of the other scary parts about this vulnerability is that the way it works is in the control channel of SSL, so you don't have to be authenticated quite yet with your client certificate. So you can access this before you've authenticated. I know some people prevent DDoS and SSL using that client certificate authentication, making sure that they're getting the right person connecting to them before they exchange any data. And this allows you to kind of bypass that because you're able to send this heartbeat before the full client authentication happens.
Mm-hmm.
So I guess one of the important things about this is, from what I understand, it only impacts versions 1.01 up to 1.01F or something like that. Isn't that right?
That's what I'm
So if
seeing.
you have something prior to that, you're okay. And if you have 1.01G, I think you're okay, right?
Correct.
I think that's because the RFC that introduced this extension was written in 2012 or updated in 2012, and that's when those versions came into existence of OpenSSL. So that's when that bug was introduced.
Okay.
So there are a number of versions, number of different distros of Linux that are affected by it. I'm not going to list them all here. If you want details, heartbleed.com is a good resource for information on the actual vulnerability. The fix for this is a little bit painful for most administrators. They either have to patch to the latest version of OpenSSL or recompile with a specific flag set to disable the heartbeat functionality.
I have a question. Has there been any work on like an IDS, IPS type solution to be able to block some of this?
So there have been a few signatures released. The ones that I've seen are mostly based on the size of the request that comes back for a heartbeat request. So if it's anything over a certain size. Stan, have you seen anything more specific than those? Maybe a byte pattern to match on?
Well, there have been signatures released with a byte pattern. I know the tool that's widely available, the proof of concept code, it has a specific byte signature that it uses. It even has a specific sequence of events that people can key in on. You just shouldn't rely on that because it's easily modifiable, and somebody else could write code that uses like random values and things like that besides the natural changes in the traffic. So actually those signatures, and you'd have to test them, the IDS signatures that you're referring to, Matt, the ones that use they'll look at the size, try to interpret it, and make sure that that value is within sane bounds. That would be a good signature, but it would have to be tested for your environment to make sure that there is no consequences of just arbitrarily blocking something just based on an IDS signature.
Right. And I guess there's some tools out there as well we know there's tools that will leverage the exploit, but I think there's some other websites that will assist you in testing your website to let you know whether you have that vulnerability or not. So we might be able to find some links for that to put up on the show for people to check out so that they could see whether they're exposed to this vulnerability or not.
Yep, sounds like a good idea.
All right, so the next story we have, so there's a botnet composed of browsers. And I think you had looked into this one, Matt, as well.
So there was a botnet composed of browsers. For a very brief amount of time, researchers at the Encapsula company had reported that they were aware of a very popular website, something in the Alexa top 25, which, if you're familiar with Alexa, is, it's a ranking of most popular websites on the entire internet. If you're in the top 25, you're big, you're huge. The only other hints as to who it was, and they refused to tell people who it was, is that it was a video hosting site of some kind, and it supported user profiles. If you look at the list, there's several sites there that can fit the bill.
I can think of a few off the top of my head.
Definitely. So, all speculation aside, whoever this was, there was a bug in the code that was handling user profile icons, such that you could upload an icon for an account that would actually contain JavaScript. You can see where this is going.
Yeah.
So they create a user account, give it an icon that contains JavaScript, and that JavaScript launches AJAX requests in that user's browser when they go to the page to attack a third party. And what they would do is they would set up an account like this, possibly multiple accounts, we don't know, and then go comment on as many videos as they could. So as long as that icon got loaded, because they commented on the video.
Right.
Yep, so anybody viewing any of the videos that were commented on was part of the botnet. So that way you can quickly build a huge amount of
right. So
bots.
You don't even have to wait for that. Like that person who set up this account doesn't have to wait for people to come to their page with their videos. They were commenting on other people's videos, and anybody who looked at those videos would load that malicious JavaScript in that image as well.
Precisely.
Okay, I missed that in the original thing. So that's interesting.
Yep. And it shows that you don't actually have to infect anybody to build an effective botnet for DDoS. All you have to do is put your code somewhere you know people are going to end up.
Right. And then the code was engaging some kind of DDoS against particular targets. That's what the JavaScript was doing in that image. Okay.
I wonder, could you also use that kind of technique to steal credentials from the user if they're signed into their webmail or something at the same time?
You could probably steal them from that very site itself. And cross-site scripting, which is kind of what was going on here, is exactly used for that sort of thing all the time, stealing cookies.
Right. You could definitely write some JavaScript that whatever, gets the cookie and then sends it to someplace else with the JavaScript if you've got that level of access to the browser at that point.
Yeah.
Interesting.
Right, and this was actually, obviously there's a lot of cleverness involved in this particular attack. One of the things that rang with me is that it looked very familiar, very similar to that mobile low-orbit ion cannon that basically there was intended for mobile devices to be able to participate in a denial of service attack. It was all JavaScript based, but this is a case where they were effectively compelling you to be a participant as opposed to voluntarily being a part of it.
Right. The big difference is that JS-LOIC, which I think is what it was called, would actually ask you to click a start button to participate in the attacks. It wouldn't automatically kick off. Right. I mean, it's a matter of changing 2 or 3 lines of code for that to happen anyway. So
right.
I'd be interested in seeing what the actual attack code looked like and if it had any sort of relationship to the old JS-LOIC code. Because
I think that's open source, if I remember. I mean, it's out there.
It's out there.
I don't know if it's open source, but it's definitely out there to read through and modify.
I guess once you put something in JavaScript, it becomes always open source.
For the most part, right.
Well, I guess another observation is that the folks that did this analysis indicated that they thought it was a proof of concept. In fact, that's a good possibility. We're going to have to see how this develops. And certainly, it really kind of, I think, increases the necessity to be paying attention to these cross-site scripting issues.
Although, if it is a proof of concept, it's a heck of a bug to burn on a proof of concept, if you know what I mean. If you have cross-site scripting at an Alexa top 25 site, that's not something any intelligent attacker would just use for a proof of concept. They'd save it for when they really wanted to use it, in my opinion.
Good point. Perhaps it was the research benefit of it.
Right. All right, well, another thing to keep an eye out for. You never can trust where you go to on the internet with your browser anymore, Yeah. All right, so the next story, I think, Stan, you were looking at this one. Top-selling app in the Google Play Store was just a scam. I think this is a story we've heard before, but maybe another version of it.
I think this story tends to repeat itself. It's definitely happened before in the Windows, regular PC, desktop environment that we're familiar with, and definitely has happened before in the Android space. I think it's Android Police, the forum. They've reported that there's this app on the Google Play Store that kind of doesn't do anything. So you download it, it tells you can scan for viruses, and then it very quickly tells you have no viruses found. And so they found that to be a bit odd, so they took it down, they reverse engineered it, they looked at the source code, and they found that, yep, indeed, it doesn't do anything. It just, as soon as you click the next button, it displays the next screen that tells you you're okay. And one of the problems with it is it's basically duping users out of $4 every time that they decide to pay for it. And the strange thing about it is that it had like 4.5 stars as its rating, which is really strange, right? Because you use those stars to kind of guide your purchase decision when you go on these Play Stores. I think we also have observed stuff like this in our own research with the Droid Not Compatible malware, where it has led us down the path of finding similar, I guess the term is crapware, apps that don't really do anything but have lots of downloads and lots of positive reviews. So something to always be aware of.
And I think, Matt, you had one time, maybe a few months ago, kind of talked about the how you can't really trust these ratings and rankings of apps on these app stores, and sometimes they leverage a lot of the reputation of existing apps to try to increase, the ratings and rankings, and then they seed it with false reviews and stuff like that. So,
It actually reminds me of another story like a few months ago as well, in terms of reputation, where there were Firefox plugins that people were paying money from buying the plugin from the developer and then leveraging that trust to dupe the users, to continue having it, but now doing some ulterior motive. I think in that case they were displaying pop-ups.
Yep. They turned it into adware. It's the reputation that's the vulnerability there.
Right. The funny thing I think about this one is that it's supposed to be an antivirus program, and the people who downloaded it and ran it, when they clicked on scan now, it came back right away. And anybody who's used any antivirus out there knows that no antivirus in the world comes back immediately. It sometimes takes hours for it to finish scanning, especially on a regular computer, right? To do a full scan. So obviously that immediately raised some alarm bells in their head that something's not right here.
If that app was still up, I would have loved to read the reviews. Maybe the 5-star reviews were that it ran really quick.
If I'd known, because I was in the Google Play Store this weekend, and it was there. It was in like 2nd or 3rd place. And I guess I just sort of assumed it was just another app at that point, which is exactly the point, All
right, good one. So from the mailbag here, we have a viewer question. We get questions from time to time. We always encourage you to send in your questions. This one, the question is that support for Windows XP actually ends today. And regarding the security, what are the biggest concerns around that? The fact that it's completely end of life now, Windows XP, and what do people need to be worried about? Thoughts, anybody?
My thoughts would be that, it's like any other operating system, except now it's not going to get patches. So there's always going to be the potential for 0 days. If they're going to be there or not is not clear. It's likely that over time, there will be more 0 days, and Microsoft is just not going to patch them. So at that point, you'll be vulnerable. To me, it seems like the people who are most vulnerable to having unsecured XP systems will probably not update their XP systems because, hey, they have a laptop and it works. Actually, I was listening to the radio today in the morning, and it was a radio reporter saying that he doesn't want to switch because his laptop works for him, and most people, that's what they hear, and maybe, how they feel. I have something that works, why should I worry about it? I can't install a new operating system on it because that equipment doesn't support the new operating system.
Well, Stan, one of the things that I had heard was that some people are maybe concerned that their systems are going to quit working. And that's obviously not the case. That's just the updates that they're going to cease. It's not actually, XP is going to stop working for folks. We had some discussion about this last week on the show. Folks can go back and take a look at that. We had a little bit of debate. I think somebody had suggested that, perhaps really the most significant point of vulnerability that will continue on is potentially in the browser itself. That is, for the most part, the operating system itself, if there's a bug that's in there, it's most likely have been discovered. So one approach might be to actually use an alternative browser. The Internet Explorer probably won't be getting updated anymore, but you could perhaps go with another browser that will continue to get updated and still works with XP.
Well, one point I'd like to make is that bugs will continue to be found in every version of Windows. And XP is the one version that it won't get patched. So if there are still shared libraries and shared code amongst the versions of Windows, they will get patched in 7, 8,
right.
Possibly even Vista. But XP is the one ground where they're not going to be patched. So I feel like the exploit development, people are going to think, XP is no one's really using it anymore, but it doesn't much matter. It's still a target, if even indirectly.
Right. I think it's going to remain a target for a while. I also think that, to Brian's point, the browser being a new vector, it's been, I guess, a vector for a while. Another type of important vulnerability is a privilege escalation vulnerability, which has a big room, even in the lifetime of exploiting through the browser, because these days, and this is not true for everyone, but users don't necessarily have admin privileges, so being able to find exploits that escalate privileges and having the entrance through the browser and then escalating the privilege will give them more access to install rootkits and things like that.
Yeah, well, that's actually perhaps a good point. One of the big benefits that I've seen with the later versions of Windows 7, Windows 8, is that they do a better job at managing the administrator role in comparison to XP. That was one of the things where you could, have restricted privileges associated with XP, but I found that a lot of applications broke. And there were other cases where it was just kind of clunky. It's handled much better in the newer versions.
Now, do we know if Windows XP Embedded is also affected? I would assume
With
it
the
is.
end of life, I don't know for sure. I would assume so, but I don't know for sure. Right.
Then it puts it in the same arena as Internet of Things sort of devices that aren't as well managed as you would expect.
Right, because there's a lot of these embedded devices like ATMs and whatnot that run XP as the underlying operating system, right?
Medical devices as well.
Right. Good point. I'm going to chalk this up to the fact that Microsoft made a really good operating system with XP, in my opinion. Compared to some of the previous ones before it, once people moved to XP, I think they're a lot more reticent to upgrade. And they look at Windows 7 and Windows 8, and they're like, well, am I really getting any more value added beyond what I have with XP nowadays? And I think that's why maybe there's still so many people holding on to that version, even though I personally like 7 and 8 as well. But it's their own fault for making such a good version of the Windows operating system.
Well, it's taken me some time to migrate as well, myself, just because I did enjoy XP and I had gotten used to it. But now that I use a 7 primarily, I quite enjoy it as well. I guess it's just adapting to the change.
Yeah, it's that transition. People are they're reluctant to go into something that's going to be a big change. And there is quite a bit of change when you go to 7, and even more so with 8, with the whole dashboard thing or whatever the heck they call that now. So
I think it's also important to know just about that story that Microsoft is offering support if you pay them money, and that you can buy buckets of hours from them, and then maybe they'll write the patches. So I think some of their big customers are able to sign on for contracting services and do that. I think actually some big government agencies are doing it.
Yeah, I wonder, there's a value proposition there of, do I want to spend the money to have Microsoft patch this old version of an operating system that they don't even want to support anymore, or should I just upgrade all my devices that are running on this old version? So people will have to decide that themselves, but I think it's better to move up if you can. So, all right, so let's jump into the internet weather and take a look at what's been going on there. I kind of I've been doing this a lot more lately, where we flip the order of things here, and I kind of like to take a high-level look at what ports are being scanned first, and then we'll go take a deeper dive into each of those, or whichever ones actually apply to worthwhile to look at here. So in terms of the most probe ports, we have SSH, 123 UDP, which is the NTP protocol. That one we know that's been used a lot for abuse with reflection attacks, just like the DNS protocol has been used historically.
Yeah, I kind of wonder, John, a lot of folks have been paying attention to NTP attacks, and I'm kind of, and of course, doing work to try to correct the problems. I'm wondering if this one has showed up as a result of folks that might be looking for vulnerable devices, perhaps not even for malicious purposes, but perhaps to help with the notification processes. Just a theory, there are a number of folks, obviously, that are doing that sort of activity. I'm sure that the malicious actors are doing some of the same. So both of those would contribute to getting that on the pie chart.
Right, and I guess you might be able to tell a little bit more maybe if there's not so many unique sources scanning for it, but there's a lot more scanning overall. That's kind of what we're looking at here, is that there's more scanning in general, not necessarily a lot of people doing it, but volume of total scanning, which might lend to your theory that it's maybe some good guys and maybe some bad guys just trying to identify what devices can be used as part of those attacks, either for their attack traffic or for the good guys to tell people to remediate these devices. So.
Right. Well, and it's also important to keep in mind that what we're looking at is a snapshot for a particular day. And it has not been consistently showing up, so it indicates that the activity was relatively short-lived.
Right. The next one on the list here, 445 TCP, that's kind of famously associated with Conficker, although there's other botnets that leverage that one. There's a pretty well-known vulnerability against that that's still out there. probably a lot of XP machines vulnerable to that one. 5,000 TCP we've talked about before on the show. This, for a while, was holding the top spot position. It's actually gone down. We're going to take a closer look at that one as well. This is a particular port. We've seen a lot of embedded devices scanning for it, and the vulnerability they're leveraging is against the Synology Disk Station Manager software. There's a vulnerability in there that they're looking for, so that's probably what that scanning is related to. The 23 TCP is Telnet, and we see that one being scanned for all the time. A lot of brute force attacks once they identify a device that's answering on Telnet. 1433 TCP, that's your Microsoft SQL Server. 80 TCP web servers. You know, we see a lot of web servers being scanned in general. There's a lot of various reasons for that. ICMP echo requests as well. That's probably innocuous for the most part. 3389 TCP is RDP, Remote Desktop Protocol. We know why they're scanning for that, because that's another brute force type of thing that they're going to try to leverage. They're going to keep trying password guessing until they can get into your remote desktop that's open. I highly recommend you do not open remote desktop open to the entire world. 443 TCP, SSL, HTTPS rather. I would not be surprised to find more of this, you know, on the tails of this recent Heartbleed bug that we just discussed earlier. So we'll probably need to keep an eye on this as the days unfold and weeks to see if we see more people scanning for HTTPS that they can try to leverage that vulnerability against. Might not be necessarily something you need to scan for in order to find it, because there's a lot of other ways through search engines to find the ones that you're looking for, but still might be a method of identifying additional devices. And this is the most sources scanning. So if you took a look at how many sources are scanning individual ports, this is what you would see. Not surprisingly, 445 TCP is in there. Those are usually configure or other types of infections related to that. ICMP, this is port unreachable, right? This is 3.3 is port unreachable. These probably, the 3.3, the ICMP echo request, and the ICMP echo reply 00 slice, they're probably all related. So you got the guy in the middle here doing echo requests out to find anybody who's going to answer. A certain portion of them are going to come back with these, you know, port unreachable, the 3:3, and then another portion are going to come back with, yes, I'm here, with the echo reply. So that's probably what we're seeing relative to those. The 23 TCP Telnet, we already talked about that. Then we see these zero-access botnet ports, which we always talk about. That's still out there. It's gone down a bit, but it's still pretty sizable in terms of how many devices are out there infected with zero access. That's a peer-to-peer protocol that they use. And then ADTCP rounding it out here. So let's take a closer look at some of these here. So the first one I want to talk about was 23 TCP Telnet. We've discussed this over previous episodes. This is just a continued look at what's been going on here. It's pretty much consistent. It's gone down slightly over the past couple of days or so here, maybe the past week. We've attributed a lot of this activity to these embedded devices, security camera DVRs, as well as other types of embedded devices. The sources scanning for this, even though they're those types of devices, they are different than the ones scanning for 5,000 TCP. So it's different sources, but they're the same type of devices. So I kind of think that this is either one botnet that's been segmented to two different functions, or it's two different actors running two different botnets with the same type of devices that they're harvesting as part of their botnet. We talked about 5,000 TCP. This is that Synology Disk Station Manager vulnerability. That's what they're scanning for here. It's kind of been trending down lately, although we still see this sawtooth pattern. I guess we'll need to keep an eye on it here. It seems to kind of be trending down a little bit, but hopefully it doesn't resurge again, because at the beginning here it wasn't that much either. The next one on the list here, and I think Brian might have talked about this last week or previous weeks, 28017 UDP. As far as we know, this probably appears to be innocuous right now. It's definitely, what we're actually looking on this slide here is the number of scan sips per hour scanning it, and it keeps increasing at a very linear rate here, and now it's kind of leveled off. As far as we know, the only port that we actually know it's concretely associated with is MongoDB. I have a feeling it's not related to that. I think Brian might have done some analysis, might have determined this might be related to gaming in some sort. Is that right, Brian?
Yes, that's correct.
Okay. So probably not anything to worry about just yet, but one of those things on our radar that I'm personally not quite sure what this one's all about yet, so I'd like to be 100% positive, even though we're pretty sure it's innocuous. And then the last one on the list here was an interesting one. So in the past few days, let's see, what is this? Maybe 4 or 5 days, we had a big ramp up of scanning on 58455 TCP, which I didn't know anything about. I took a look at the sources doing it, and it was a small handful of sources, mostly scattered around the Asia-Pac area. Most of them seem to be embedded devices again, kind of like the 23 TCP scanners and the 5000 TCP scanners, but I noticed it's a different kind of mix of devices. It's not the same kinds we had seen before, and maybe that's something to do with the geography as well. I'm not quite sure. But then when we were at lunch, Matt said, wait a second, 58455, that rings a bell. And I think you're right. I did a little more research after lunch today, and you mentioned it was the Zollard botnet was one that was scanning for that. I pulled up some of the info on that. So this article here from Deep End Research, who are some researchers, and they did some analysis of the Zollard botnet back in December of 2013. So not that long ago, 3 or 4 months ago. And this is an interesting one in that it uses PHP. So if you have a web server running on some embedded device, it tries to leverage a PHP exploit to drop, basically leverage a shellcode exploit so that it can, tell the machine to go fetch some executables. It goes and fetches them and will run whatever one applies. So it actually will download binaries for x86, MIPS, ARM, PPC, all kinds of various hardware platforms, and then figure out which one it actually needs to run and run the right one. And the other interesting item about it is that it uses, when it leverages the exploit, it has a user agent of Zollard, which is where it got its name from. And once it's compromised the device, and it's, again, this is embedded devices, and you'll notice from the article it says, leave my Internet of Things alone, which is what we kind of call these embedded devices that nobody really touches. They're these things that are out there that aren't PCs. And once the Trojan runs on the machine, it opens up a port listening on port 58455 TCP, which is a backdoor, and then it also starts scanning for other ones. So that's probably what this, I'm going to guess, it makes sense that that's what our scanning activity here is related to. And it will also try to do some brute force telnetting attempts as well against devices. So that, PHP as an exploit vector might not be the only way that you can get compromised by this, because it seems to do some brute forcing as well. But an interesting one, and just another example of, okay, there's a lot of people out there in various forums creating botnets around these embedded devices that people really probably don't touch very much. They put them on their network and they just run. So, you've got your home routers, your cable modems, your network attached storage, your DVRs, your various, et cetera, et cetera, et cetera.
Your
Smart TV, right.
Sure.
Right, and you might not, and once they compromise that, they might not even know that you wouldn't necessarily know it's compromised unless
there's no AV scan for your smart TV.
Right. All right, that's the show for today. If you'd like to get in touch with us, you can always email us at threattrack@list.att.com. We always encourage you to send us your feedback and questions for the show. We'll try to bring them up. You can also find us on Twitter. Our handle is @ThreatTraq. And the ThreatTraq video is available on att.com/ThreatTraq, as well as on the AT&T Tech channel on YouTube. There's an audio-only version on iTunes. And thanks for joining us today. Thanks, Matt and Stan and Brian, for joining us. And we'll be back next week with a new episode. Until then, keep your network safe.